Hello, I'm Chris Alvarez and welcome to Spacewalk's Money Talks, where we talk about the business, policy, and technology behind space exploration and commercialization. We're on the web at spacewalksmoneytalks.com. Thank you for listening. Hi, I'm speaking with Dr. George Sebestyen, one of the co-authors of Low Earth Orbit Satellite Design. Thank you for speaking with me.
Thank you.
So first, tell me about your background in the field of space.
Well, I got a doctor's degree in electronics from MIT. And then over the next 28 years, I worked in the defense electronics industry, including large satellites. At some point in time, I started my own business.
Mm-hmm.
We built mostly surveillance systems, and we got into satellites more or less by accident.
Mm-hmm.
Over the next 10 years, we built about 34 satellites for various customers. We also built ground stations, and we operated some of the satellites for our customers. Our customers ranged from Air Force, Navy, NASA, and some foreign governments.
Now, at what point are you into microsatellites? Is that the proper term?
No, the satellites we built ranged from 150, 200 pounds to about 3,000 pounds.
Okay.
The smallest ones we actually built weighed about 50 pounds.
Mm-hmm.
And they were for many different missions, ranging from communications to science, remote sensing, and so on.
Now, this book, I see, the blurb on the book, but in your own words, can you tell me what this book is about, what it focuses on?
Yes, it focuses on the design of small, low Earth orbit satellites. Not as small as cubestats, but small.
Mm-hmm.
And it covers all aspects of the satellite hardware and software design. It covers the design of structures, electric power, attitude control, digital processing, communications, and thermal design. A chapter is devoted to each of these subjects, 21 chapters in total, including one that allows one to download design software.
So now, considering how broad, how many topics this book covers, what would you say its focus is on, and that it can't hit everything in detail? So how do you sort of break it down? What do you specifically aim at?
I specifically aim at the hardware design. It does not really discuss how to design what the mission should be, nor what orbit altitude it should fly at. Those are assumed given. It is really for the design of hardware.
Okay. So what would you say currently, what are the challenges in space tech, business, technology, or policy that you're most concerned about, and why?
I think my main concern would be that with the number of different companies or entities entering the space business, which I think is in excess of 100, they all cannot possibly make a living. Also, there are a number of companies that want to build satellite constellations for communications and remote sensing. So, too many companies are in the business and they cannot all succeed. There will be a large fallout, and it won't take too long for that to happen. Probably in the next 5 to 10 years. The companies will sharply decrease in number.
So that leads to my leads to my next question, which is as far as the hardware design, how do you count? People talk about how the low Earth orbit is becoming so crowded. How do you account, or do you need to account for maybe more debris in that area, or just a larger number of satellites? Is there any special precautions needed?
Well, it may be needed, but you can't. Maybe new technology is needed. I believe the Naval Space Surveillance System tracks on the order of some 10,000 objects, which range from small spent boosters to specks of paint. And when you add to this number the number of satellites that are planned, several thousand, then there will be a crowded space. However, that does not mean that the probability of collision will be very high. Space is huge. The government is now requiring that you deorbit satellites when they finish their missions. Well, that's a tall order because it increases the size and cost of the satellites tremendously. And most of these satellites do not have too much redundancy in hardware and software. So the satellites basically just crap out. So you cannot deorbit it because it is dead. You could deorbit large satellites, which usually have a lot of redundancy, but you probably cannot do it with small satellites.
Interesting. So talking about going back to the hardware design, have there been any innovations in, say, the last 5 or 10 years? Has this explosive interest, I guess it's always been a strong interest, but it seems that more and more people are getting into this. Have you seen any big advances technologically?
Well, yes. I don't know about big, but significant. For instance, solar cells. Efficiencies 20 years ago used to be in the teens, say 15 to 17% efficient. Today they are 28% efficient. So they are twice as efficient, so that one would require half as large an area and a smaller structure. Another area is attitude control. The attitude control needed for imaging satellites needs to be fantastic. And while you could buy such attitude control system hardware, the cost was sort of $1 million a piece. Today you can buy a 3-axis attitude control system for less than $100,000 that achieves more or less the same kind of accuracy. And these advances, both the 3-axis stabilization and just because the need arose, resulted in tremendous changes in satellite hardware construction technology.
And your book addresses these things, I assume?
Well, it does not address the evolution, but it does address how they work.
Yes, I'm sorry. That's the question I meant to ask. That your book talks about current designs in those respects.
Yes, current designs.
So I noticed also your book, it pointedly mentions universities. You know, this book helps universities, among others, design satellites. Are universities and similar customers, do they need to watch their budget closely when they design satellite?
Absolutely. They usually have no money. So they are restricted to building very small satellites. They build cubestats for which there is a definition of the size of the structure that it needs to be. And because they are small, they don't cost much. You know, satellite costs are basically cost by the pound. So a small CubeSat could cost below $100,000. And universities typically collect freebies from industry, so that helps their budgets also.
So what other designers would find this book useful? Who else is it aimed at?
It is primarily aimed at the design engineers who work in companies that build spacecraft. That is the focus. There are books that cover how to construct satellite missions. That is, how to decide what orbits to go into to achieve a certain purpose. This book strictly covers only the hardware aspects, the hardware and software.
And software as well?
Yes.
Okay. So how much does the book, again, I understand it's just about the satellite itself, but how much does it touch on ground communication issues? the hardware and software?
Quite a bit. Satellite-to-ground communications is one of the main factors in satellite design, and it is one of the difficult ones. You usually do not have enough bandwidth to achieve the desired data rates. You do not have large antennas, for satellites are small, and you're not allowed to transmit more power, or else you exceed the RF illumination density established by the FCC. So there are counterproductive aspects that make it difficult to design a high bandwidth communication system.
Mm-hmm. Are there any aspects of a satellite's design that you think perhaps people don't focus on enough, or that you'd like to see more of an emphasis on in any way?
Reliability. These small satellites tend to be what we call single-thread satellites. In other words, there is no redundancy. As a result, lifetimes are short. While the satellites cost less, they also don't live very long. So the cost per year is not all that low. So you need to focus on how to improve the reliability and radiation hardening without incurring the high cost of high radiation tolerant components.
I don't know how much you get into this or how much you're aware of this, but material science, are there any new materials being developed that that really help with satellite design?
I don't really know. There are some 3D printed structures that some people have used, but that doesn't really save that much. However, in the area of new propulsion systems for small satellites, there are considerable advances.
Are you talking about technologies to orient the satellite once it's in orbit, or during launch?
To orient it while it is in orbit, or to make up drag so it doesn't deorbit.
Okay. That's actually my next question. I was hoping you could discuss with a little bit more detail those technologies used to adjust a satellite's orientation and their flight path.
Most of the satellite orientation is performed by the attitude control system, which has reaction wheels or gyros, typically 1 to 3 gyros. When you accelerate one, the satellite starts to turn in the opposite direction. That is how you orient it. Propulsion systems are used mostly for station keeping. If you have a constellation and want to maintain the relative positions of satellites, or you need to reach your assigned position from where the launch vehicle left you off. These maneuvers require more energetic propulsion systems. Typically, a small satellite used to use cold gas nitrogen propulsion systems. Bigger satellites or larger energy requirements are filled by liquid hydrogen systems. These are the traditional propulsion systems that have been used. But now, electric propulsion is starting to come into play, as well as other chemicals. The field is very fluid, and it will be a number of years before this all shakes out.
Mm-hmm. So right now, I assume it's still sort of in the testing phase and kind of expensive if you were to implement these new technologies.
Yes. And these typically provide smaller impulse, so they require longer burn times.
Mm-hmm. I'll go back a little bit to sort of some policy type questions. Do you see any challenges in the efficient design of satellites that could easily be fixed or addressed either by business or government, maybe any kind of regulations?
Well, I don't see at the moment that regulations impede satellite design too much. There are a few things, obviously. Frequency allocation imposed by the FCC is one. the spectrum is limited, and if you have too many satellites, they all want to talk, and their footprints overlap on the Earth. So there's a serious RFI, radio frequency interference issue. So there must be some way to regulate them. So that's one of the regulation issues. The other is mitigation of the number of objects in space to avoid collisions. Objects live for decades. You cannot continue to launch hundreds and hundreds of satellites each year without eventually getting to the point where there is a real problem.
How much familiarity do you have with the research into sort of debris cleaning technologies, sending maybe satellites out there to clean up after other satellites? Is that still, far in the future, or how close do you think people are to that sort of technology?
Frankly, I don't know. What I know about it is that it is going to be a very difficult task.
How about the use of radioactive materials in satellites? I actually don't know if they're used at all for anything. I know that they're used in some space endeavors, but I don't know. Can you discuss that?
Well, the only radioactive materials used in space are in nuclear power plants that were used in deep space missions, not used in low Earth orbit. In deep space missions, where you really cannot use solar arrays, people have used nuclear power plants.
Now, has anyone ever suggested using any kind of radioactive fuel for low Earth orbits, or would that be technically just unsound?
Not that I'm aware of. I don't know of any nuclear power propulsion systems. I know of nuclear power generating systems.
Mm-hmm. And I say that because I know there are restrictions on sending nuclear material up into space, and I'm just wondering if there are any people arguing to get rid of regulation or reduce regulation as far as that goes, and in some way it will help with satellite design.
So far, it has not impeded satellite design. We don't really need it.
Okay. What excites you about satellites and space? What do you see as the next big thing, maybe?
I think satellite constellations for remote sensing is probably the next big thing. I don't know how many of those now proposed will actually be built. I know that SpaceX, with their planned internet in space, is very ambitious, and they also have money. They have launched so far a fair number of precursor satellites towards establishing a constellation. Several smaller companies or new startups that have proposed constellations probably won't be able to get enough funding to actually build them. One of the issues is that going into the satellite business to build satellites is not usually profitable. The satellite builder does not get rich. The fellow who uses the satellites for some good application is more likely to get rich. I always have been in the building end and did pretty well, but I have never been the user of any of my own satellites.
Could you imagine a future consolidation of space, a satellite construction business, to where someone could try to monopolize sort of some part of it or try to get rich in some way?
We started out with a consolidated situation where there were only large satellites. There were only 4 or 5 companies in the country, and maybe a total of 6 or 8 in the world that built satellites. Today there are hundreds that are trying. Some will succeed, but most are in the planning stages at this point and will most likely fail.
Mm-hmm. Yeah, it seems, when I look at this, new space, as they call it, it seems like there's an incredible amount of speculative money going into it. But, there's not, like you said, there aren't going to be many survivors at the end of it. So I'm just kind of fascinated at the number of people who are willing to take that gamble.
Look at the start dates of the new starts. In the 90s, say in the year 1995 or so, there were only about one or two companies a year that started. Then, starting about 2013, the number of new starts ranged from 30 to 50 each year. So you now have something like a couple of hundred organizations meddling in satellites. There is no way that all of them could survive.
So just to turn quickly to government, federal funding for satellite design. You know, when NASA, in the early days of NASA, they developed new technologies and then they were pushed out to the commercial sector who could make use of them. Is there, as far as low Earth orbit satellite design, is there anything, is NASA or any other, some other nation's space agency, are they developing any new technologies that can go out to the commercial sector, or is it all basically the commercial sector doing the advancement now, do you think?
Yes, for instance, the Defense Advanced Research Projects Agency, DARPA, funds usually pretty far out technology with an intent to be used by services or by commercial entities. I got my initial funding from DARPA also.
Mm-hmm. And that sort of kick-started what went on afterwards, your progression, your professional progression.
Yes. First were DARPA-funded satellites for specific uses needed by the government, and then later other government agencies continued to buy satellites for different purposes, not necessarily based on the same technologies.
Do you think China is developing satellites, or can you imagine China developing new technologies, satellite technologies that they might not share with others and maybe establish some sort of dominance in some way, in some aspect of satellite design?
Well, China has an indigenous launch and satellite building capability. For instance, they have the capability to go to the moon. Now, during the development of these things, they will probably develop new technology if needed and if it has to be invented. So I wouldn't put it past it. It's quite possible.
So where can people find you on the web or maybe your other authors?
Alex Chukra is the person who wrote the chapter on thermal design. He is an independent consultant, although he works mostly for NASA. Nick Galassi wrote the chapter on structures. He is also an independent consultant, but he also works for NASA most of the time. The guidance and control chapter was written by Steve Fujikawa, who had his own company. He is now the chief technical officer of the company he had. He is a guidance and control specialist. I wrote the 18 other chapters. I had my own company building satellites. I sold it. Then I started to consult.
All right. Well, that's all the questions I have. Do you have any last thoughts or words?
No, other than perhaps that the hype of small satellites of the last few years has generated a number of companies and many young people getting into the field. I think that eventually the number of people in the satellite business will exceed the requirement. While this won't happen for another 5 to 10 years, I would be very careful getting into the satellite business.
Interesting. All right. Well, I thank you very much for speaking with me. It was quite enlightening. Thank you for listening. The best way to support this podcast is to rate it on Apple Podcasts. You can get more information at spacewalksmoneytalks.com. You can also follow us on YouTube at Spacewalks Money Talks, on Instagram at Spacewalks Money Talks, on Facebook at Spacewalks Money Talks, or on Twitter at Spacewalks MT. Thank you for listening.